First of all, today I'm going to discuss about the class 12 mathematics related to the chapter 1 complex number. Complex number is most important, and in the complex numbers, I'm going to I was describing about point number 6, and then now today I'm going to discuss about say point number 7. Find the complex number in the polar and Cartesian form, so that this compound is e power I phi, and so find the complex number. Find the complex number in the polar form and the Cartesian form, so that at first of all solution. Then the question is our question is I phi e power I phi, and then the change into the exponential change into the Cartesian and polar form. The formula is cos phi minus plus I sin pi, and this is called the polar form. And minus 1 plus I into 0, so that one answer. Then this is called the Cartesian form. And another question is question number B. Question number B is e power minus minus I pi by 4. Then the exponential is changes into the polar form and the Cartesian form. The formula is solution. At first of all solution, and e power minus I pi by 4, and then the e power I pi minus pi by 4, and then the exponential is change into the Cartesian and the polar form. The formula is cos minus pi by 4 plus I sin minus pi by 4 this is called a polar form. And cos 45 the cos is this is negative, so that cos is positive, so that minus I sin, this is minus is already in front side of the sign. So that I sin 45, and the value of the cos 45 is 1 by under root 2, and then minus I the value of the sin 45 is 1 upon under root 2, so that this is called the Cartesian form. Cartesian form. This is called the Cartesian form. Answer the next example. Next exercise is C 3e power I sin I pi by 6 solution. And this question is 3 into e power pi by 6 and the 3 is in front side of this questions. And cause the exponential formula is converted into the polar form. This formula is cos pi by 6 plus I sin pi by 6, and this is called the polar form. And 3 cos pi by 6 means cos 30 plus I sin 30, or similarly cos 30, and the 3 cos 30 the value of the cos 30 is under root 3 by 2 plus I the value of the sin 30 is 1 upon 2, so that the 3 under root 3 plus I by 2, so that 3 by 2 under root 3 plus I. This is called the Cartesian form. So that then another question is question number 8. Question number 8 is express the following the complex number into the exponential form. Then the first of all now I'm going to discuss about the question number 8. Question number 8 means express the following. Express the following the complex number complex number in the exponential form. And then this is exponential form, and the question is our question is question number 1, under root 2 plus I under root 2 let zb under root 2 plus I under root 2, and then the equation 1, suppose the equation 1, we can suppose equation 1, then the here here compare with x plus iy, the under 2 plus I under 2 is compared with x plus iy, then the x is equal to under 2 and then y is equal to under 2, so that by using the we know that by using the formula by using the formula r is equal to the formula is r is equal to under root x square plus y square, and then the r is equal to the value of the x is under 2 square plus the value of the y is under 2 square, so that the r is equal to plus 2, then the under 4, and then the r is equal to 2. Our value is 2, and so that theta is equal to that 10 inverse y upon x, so that 10 inverse under the value of the y is under 2 and the value of the x is under 2 cut, so that 10 inverse 1 only 1, so that 10 inverse 1 value is pi by 4, so that now the equation 1 becomes the polar form and the Cartesian form is converted into the exponential form. Its formula is z is equal to r e power I theta. It is most important in this formula, and z is equal to the value of the r is 2 and the value of the theta is pi by 4, then it is called change, so that it is answer. It is our answer. Then the question number B, the question number B. Question number B is 1 minus I. Solution at first of all, the solution that z is equal to 1 minus I, and then equation 1, and I minus 1 minus I is compared with the x plus iy, so that the two change into the polar form, so that x is equal to 1 and y is equal to minus 1, and by using the formula r is equal to under root x square plus y square, so that under root the value of the x is 1 square plus the value of the y is minus 1 whole square, so that under root 2 under root 2, and then the r is equal to the value of the r is under root 2, then the theta is equal to 10 inverse y upon x, theta is equal to 10 inverse y, so that the 10 inverse of the value of the y is minus 1 and the value of the x is 1, and then the 10 inverse of minus 1, so that the value of the 10 inverse of minus 1 means 135 degree 35 degree. Then the now equation 1 becomes we know that the polar form is converted into the exponential form. The formula is z is equal to r e power I theta, so that z is equal to the value of the r is under root 2 and e I theta, the value of the theta is 3 pi by 4, so that z is equal to the value of the z is under root 2 e power I 3 pi by 4, then our answer is z is equal to under root 2 e power I 3 pi by 4, so that the answer. And another question is point number AC, and let z is equal to minus 6 plus I into 0 is equal to 1, and the two change into polar form. So that minus 6 plus I into 0 is equal to x plus iy. By using formula formula, we know that formula, and r is equal to x square plus y square, so that r is equal to the value of the x is minus 6 whole square plus y, the value of the y is 0 square, and then the value of the 6 is 36 plus 0 and 36 and 36 the value of the r is 6 so that n and the theta is equal to 10 inverse y upon x, note that, and then the 10 inverse the value of the y is 0 upon the value of the x is 6, so that 10 inverse 0 and the value of the 10 inverse 0 is pi, so that now equation 1 becomes equation 1 becomes so that z is equal to re I theta, and this is formula. This formula exponential is converted into the exponential. Polar form is converted into the exponential. The formula is z is equal to re power I theta by formula. And then the z is equal to the value of the r is 6 and the value of the the value of the theta is pi, so that our answer is 6 e power I pi. Then the answer, this is our answer. Then the question number D. Then the question number D. Minus 1 I minus I under root 3, so that the solution, let z is equal to minus 1 minus I under root 3, equation 1. This is called equation 1, and the two change into polar form, and then the minus 1 minus under root 3 I is equal to x plus I y. Then the minus 1 minus under root 3 I is compared with the x plus I y. Then to give x is equal to minus 1 and y is equal to minus under root 3 minus under root 3. So that by using the formula, we know that formula by using the formula r is equal to x square plus y square, so that the value of the x is minus 1 whole square plus the value of the z is minus under 3 square, so that then the 1 square is 1, then the under 3 is 3 means under 3 means square is 3, and then the under 4, and this is called 2. R is the value of the r is 2, and theta is equal to 10 inverse y upon x. The value of the y is under root 3 and 1 minus cot, so that 10 inverse under root 3, and then the value of the 10 inverse is pi by 3, so that now equation 1 becomes z is equal to re power I theta, so that the value of the r is 2 and the value of the theta is pi by 3, so that our answer is z is equal to 2 ei pi by 3, so that answer our answer. This is our exercise, all exercise this topic. Then we are going to discuss about the exercise examples of the complex number. So that examples of the complex number, today I'm going to discuss about the example of the complex number. So that example number one, so that this example is most important. Example number one of the book 1.1. Example number 1. Then you can see that using the De Moivre's theorem, to find the value of the find the value of 1 plus I for 20 solution at first of all solution let I plus 1 plus 1 plus I is equal to compare with x plus iy, so that the r cos theta plus I sin theta then the equation 1 and the equating the real and the imaginary parts imaginary parts we get the x is equal to r cos theta is equal to 1, and the y is equal to r sin theta is equal to 1, and then using the formula r is equal to under x square plus y square, so that the value of the x is 1 square plus the value of the y is the value of the y is 1 square. So that under root 2, and the value of the r is the value of the r is under root 2. Then the theta is theta is equal to tan inverse y upon x. The value of the y is the tan inverse 1 upon 1. Then the tan inverse 1, the value of the tan inverse 1 is the 45 degree 45 degree. So from the equation 1 plus I is equal to under root 2 cos 45 minus I sin 45 1 plus I for 20 is equal to under root 2 cos 45 plus I sin 45 whole power 20, so that under root 2 power 20 and the cos 20 multiply for 45 plus I sin 20 into 45, so that under 20 under 2 power 20, then the 20 into the 45 multiply is 900 degree plus similarly I sin 900 degree, so that the value of the under 2 power 20 is 10 power 2 power 10, so that the value of the 900 in the cos 900 value of the cos 900 is minus 1, so that the plus I the value of the sin 19 is sin 900 is 0, so that the 2 power 10 minus multiply minus 1, so that the minus 2 power 10, then our answer is our answer is 10 power minus 2 power 10. And then the another example is other examples of this book. Examples 2. Example 2. Example 2. We can see that. Write down. I'm going to write down on my copy using. We can see that we given that we can given that these questions using the De Moivre's theorem. De Moivre's theorem. Find the square root of the. It is most important. Find the square root of the minus 2 under 3i under 3i. So the at first of all solution z is equal to x plus iy is equal to minus 2 under 3i is equal to r cos theta plus I sin theta I sin theta equating the, and then this question is another that equating the real and imaginary part. Imaginary parts we get x is equal to value of the x is equal to r cos theta is equal to minus 2, and y is equal to r sin theta. R sin theta is equal to minus 2 under root 3, so that we know that the formula using using r is equal to under root x square plus y square, and then the value of the x is minus 2 square plus the value of the y is minus 2 under 3 square, so that under 4 plus 12, so that the value of the r is 4, r is equal to 4. Then n theta is equal to tan inverse y upon x. The value of the tan inverse of the value of the y is minus 2 under root 3 upon the 2, so minus 2, so the minus 2 cut, so that the tan inverse under root 3 then the tan inverse under root 3 means then under 3 means under 3 means so that 100 plus 60 means 240 degree, so that 2 pi by 3, and the x and y both negative, so that both negative, so that theta lies on the fourth quadrant, so that z is equal to 4 cos 4 pi by 3 4 pi by 3 4 pi by 3, so that 4 pi by 3 plus I sin 4 pi by 3 and this is 4 pi by 3 4 pi by 3 then another then we can write down the under root z is equal to z1 by 2, z1 by 2 is equal to 4 k pi plus 2 pi 4 pi by 3 plus I sin 2k phi, sorry 2k phi 2k pi plus 2k pi plus 2 4 pi by 3 4 pi by 3 4 by 3 then the whole power 1 by 2 whole power 1 by 2 using the De Moivre's theorem we get using by De Moivre's theorem we get under root z is equal to 4 power 1 by 2 cos k phi plus k phi plus 2 pi by 3 so I sin k phi plus 2 pi by 3 and where k is equal to 0 1 square means 0 and 1 when k is equal to 0 the value of the k is 0 then the under z is equal to 2 cos 2 into pi by 3 plus pi into 0 so that plus I similarly sin theta sin 2 pi by 3 plus pi into 0 so that the 2 cos 2 pi by 3 plus I sin 2 pi by 3 and then the value of this minus 1 sorry 2 minus 1 by 2 minus I under root 3 cos 2 pi by 3 the value of the cos 2 pi by 3 is minus 1 by 2 and then the similarly in the third quadrant the value of the sign is negative so that under 3 by 2 and then the value of the minus 2 common from this bracket is 2 and then the 2 is got and so that the minus I under 3 the value of the 2 cos bracket small bracket 2 into 2 pi by 3 plus pi 0 plus I sin 2 pi by 3 is minus 1 minus I under 3 and then the when k is equal to 1 when the k is equal to 1 under z is equal to 2 cos 5 by 3 I sin 5 pi by 3 then I'm going to from the shortcut method so that 2 the value of the cos 5 pi by 3 means 1 by 2 so that so that fourth quadrant in the fourth quadrant sin theta is negative sign so that cos is always positive in the fourth quadrant and then I under 2 so that I minus I under 3 so that the square root of the values the required square roots of minus 2 under 3 I r plus minus 1 minus I under 3 so that our answer is plus minus 1 minus I under 3 and then the another example is example 3 and the another examples is example number 3 example number 3 in the example number 3 is given by using De Moivre's theorem De Moivre's theorem to find the cube root of the unity it is most important for the any exams. So that find the cube root of the cube roots of the unity. Cube root of the unity. At first of all, its solution. Let g power z power 3 means cube root, so that I is equal to 1 plus I into 0, so that cos 0 plus I sin and I sin 0, so that z power 3 is equal to cos 2k phi 2k phi plus I sin 2k phi 2k phi, then the z is equal to cos 2k pi plus I sin I sin 2k pi pi whole 1 by 3, so that z is equal to cos 2k pi cos 2k pi by 3 plus I sin 2k pi by 3 where k is equal to 0, 1 and 2 using the De Moivre's theorem. Using De Moivre's theorem. Using the De Moivre's theorem, when the k is equal to 0, then the z is equal to cos 0 plus I sin 0 is equal to 1 plus I into 0, then the value of the in the k is equal to the value of the k is 0 in place of the in place the 0 is equal to cos 2k pi upon 3 plus I sin 2k pi by 3, then its value is this compound is value is 1, and when then another k is equal to 1, k is equal to 1 is placed in the cos 2 pi by 2 pi 2k pi upon 3 plus I sin 2k pi by 3, then the value of the is equal to cos 2k pi cos 2 pi upon 3 plus I sin 2 pi by 3 is equal to minus 1 by 2 minus cos 2 minus 1 by 2 cos is negative, so that second quadrant in the second quadrant is cos is negative in the second quadrant, so that minus 1 by 2, and then the plus I sin then I plus I under 3 by 2 is equal to minus 1 plus I under 3 by 2, and that is this is another name is omega, and the minus 1 plus I under 3 by 2 is equal to omega, and then the another when k is equal to 2, and then the z is equal to cos 4 pi by 3 4 pi by 3 plus I sin 4 pi by 3 is equal to then the cos 4 by the value of the cos 4 pi by 3 is minus 1 by 2 plus I, and the sin 4 pi by 3 means under minus 3 upon 2, so that the value is the value of the cos 4 pi by 3 plus I sin 4 pi by 3 is minus 1 minus I under 3 by 2, so that this is called omega square. Hence the cube roots of the unity are at first of all 1 comma minus 1 plus I under 3 upon 2, and 1 minus I under 3 by 2, so that such that 1 comma omega is equal to omega square. Then the another examples number 4. Then the another example, and the example number 4 is if the z power bar be the conjugated complex number z conjugate of a complex number z, so that the proof that prove that as z power bar is equal to 2 pi minus as z z z then prove that we can given that we can given that prove that as arg z power bar is equal to 2 pi minus arg z, so that first of all solution let z is equal to, we know that let z is equal to r cos theta plus I sin theta and then arg z is equal to theta, we know that so that now then the z bar is equal to r cos theta plus I sin theta whole bar, and then the value is the cos theta plus no plus minus I sin theta is equal to r cos theta minus I sin theta and the z bar is equal to r cos 2 pi minus theta then plus I sin 2 pi minus theta so that z power bar is equal to 2 pi then the 2 pi minus theta 2 pi minus then the 2 pi minus theta, so that 2 pi minus arg z is equal to, this is called proof, and this is proved, so that then another examples of the examples number 5, another example number is example number 5. Example number 5. In the example number 5, we can see that question. You can see that question. So that if the z is equal to cos theta plus I sin theta, the proof that we can prove that the z power n minus 1 upon z power n, so that is equal to 2 sin n theta I is prove that so that we can see that this is this numerical is z power n minus 1 upon z power n is equal to 2 sin n theta is prove that we can given that these questions, so that at first of all solution solution here z is equal to cos theta plus I sin theta we know that the value the formula is z is equal to cos theta plus I sin theta, and z power n is equal to cos theta plus I sin theta power n this is the solve cos n theta plus I sin n theta this is this then the cos then the cos n theta then the cos n theta plus I sin n theta, this is using the de Moivre's theorem using de Moivre's theorem using the de Moivre's theorem, and 1 by z power n is equal to z then the z is upon in the z is upon minus n, so that the value of the z is cos theta plus I sin theta power minus n, so that cos n theta minus n theta plus I sin n theta, so that the cos is always positive, so that cos n theta and minus is another and fourth side of the sin I sin theta, so that minus I sin theta minus I sin n theta minus I sin theta, then we can prove that you can see that z power n minus 1 upon z power n is equal to cos n theta plus I sin theta sin I n sin theta, then minus bracket start cos n theta minus sin I sin n theta and sin theta, and then the cos n theta plus I sin n theta minus the bracket is open, then the cos n theta plus minus plus, so that I sin n theta, then the cos n theta is called, then the 2I sin n theta, this is called the proof, this is proof. So that another example is example number 6, then another example is question number example number 6. Example number 6, see, you can given that question. Question number A, express e power I pi by 4 into the polar form, and and then Cartesian form, and then Cartesian form. Then at first of all solution, and the given our given question is e power minus e power I pi by 4 is equal to cos. We know that the formula is the exponential formula. Exponential is converted into the polar form, and the Cartesian form is e power I pi by 4 is equal to cos pi by 4 plus I sin pi by 4 so that the value of the cos pi by 4 and the I sin pi by 4 is the value of the pi by 4 is 1 upon under root 2, so that plus I sin pi by 4 the value of the sin pi by 4 is 1 upon under root 2, so that so that this is called the polar form, and this is called the polar form, and this is called the Cartesian form. And another question is question number B. Express minus 1 express the minus 1 plus under 3i into the exponential form. The from question number B, at first of all solution, and we have z is equal to minus 1 plus under 3 is equal to x plus 1i. Then the minus 1 plus under 3i is compared with x plus iy. Then the x is equal to minus 1 and y is equal to under root 3. Then we know that by using the formula r is equal to under x square plus y square. Y square, and then the r is equal to the value of the x is minus 1 y square plus the value of the value of the y is under 3 square under 3 whole square, so that then the calculations is minus 1 square is 1, so that under 3 square is 3, so that the value of the r is 2. R is equal to 2, then the n theta is equal to we know that theta is equal to tan inverse y upon x, and the tan inverse the value of the y is under root 3, and the value of the x is minus 1, so that the calculation, then the pi minus pi by 3 pi by 3, so that the 2 pi by 3 the complex number in exponential form is it is most important. Z is equal to r e power I theta, so that we can write down z is equal to 2e power I 2 pi by 3. Our question, our answer is z is equal to e power e I 2 pi by 3. This is called exponential form. Then now today I'm closing my friends, so that then I'm going to describe about now I'll describe about square root of the complex number, so that the complex number, the first exercise of the complex number is finished. So that then the another next day, I'll describe about the square root of the complex number, so that it is most important. And tomorrow I'll describe about the square root of the complex number. And then the first exercise of the complex number is finished. So that next I'll start the exercise 1.exercise 2 of the complex number, so that the square root of the complex number is most important. Now exercise of the first exercise of the complex number is finished today. Exercise first of the complex number is finished today. So that then the another I will start the square root of the complex number.